The Sahara Desert. When we think of the Sahara Desert, we envision endless sand dunes and parched landscapes, not lakes. Yet recent research reveals how powerful storms can temporarily transform parts of this arid region into unexpected bodies of water. A groundbreaking study led by Dr. Moshe Arman from Hebrew University and Dr. Franziska Emisega from the University of Bern has uncovered the mechanisms behind these rare desert lakes. Their team analyzed satellite data spanning from 2000 to 2021, focusing on Sebkha el Melah in northwestern Algeria. Despite hundreds of heavy precipitation events during this period, only 6 resulted in significant lake formation. What makes these lake-filling events so exceptional? The research shows these rare occurrences happen when extraordinarily intense storms bypass the Atlas Mountains' rain shadow. Extratropical cyclones forming along the Atlantic coast pull enormous volumes of water vapor and navigate around high terrain, penetrating deep into the desert. Most storm systems lose their intensity over the Atlas Mountains. However, when powerful enough and persisting for several days, these weather patterns can deliver substantial rainfall to normally parched basins. What's particularly fascinating is how moisture can bounce through the Sahara. As raindrops evaporate before reaching the ground, they create humid air that travels further inland, producing a domino effect that amplifies water availability. The research team emphasizes that a single day of light showers isn't sufficient to create these lakes. Instead, multiple days of downpours, combined with local convection and large-scale airlifting, generate the necessary runoff. Climate models suggest rising temperatures might increase moisture transport toward the Sahara, potentially making these lake-filling events more frequent. In fact, a rare flooding of Sebkha el Melah in September 2024 followed the exact atmospheric patterns identified in the study. These findings have broader implications for understanding historical wet periods in the Sahara. Rather than steady rainfall, massive infrequent storms may have created the wetland habitats that once dotted parts of the desert. For future climate research, this suggests we need to focus not just on average rainfall statistics, but on storm intensity and moisture pathways. Higher resolution climate models will be crucial for capturing these powerful, yet fleeting rainfall events. As we contemplate the future of desert communities and fragile ecosystems dependent on sporadic water, this research provides valuable insights into how water cycles might respond to our warming planet, transforming, if only temporarily, one of Earth's driest landscapes into an unexpected oasis. For more on this story, find a link to the article on Earth.com in the description.